Welcome to this session on building modern diagram editors with Eclipse GLSP. I'm Philipp Langer. I work at EclipseSource, your open source technology partner for building custom IDEs, domain-specific modeling environments, and so on, based on open source technology. And one of those open source technologies in our toolbox is Eclipse GLSP for building diagram editors. I'm super excited to be here today talking about our latest release, the 2.0 release, which is really hot off the press. So I think the last package has been released just yesterday, just in time for this talk. I'm pretty sure the team back in the office is pretty exhausted now, but now it's done. It contains many cool new features, but today I really want to highlight the three most innovative features, in my opinion, which have been cooked up together in close collaboration with the business informatics group at the Vienna University of Technology. So big shout out to Dominik Bork of the Vienna University of Technology and these excellent master students that have been working with us on these cool features. So before I dive right into these cool new features, let me just give you a very short introduction about GLSP and what it is. So GLSP is short for Graphical Language Server Platform and is basically a client-server framework that you can use to build web-based diagram editors that you also see here, a few examples that are fully editable with a modern look and feel. And they are web-based and can then, in addition, be integrated into either standalone web applications, into desktop applications using Electron, but also integrated seamlessly into tool platforms such as VS Code, Eclipse Thea, or even the traditional rich client Eclipse RCP. Basically, the idea behind GLSP is to adopt the architectural pattern of the language server protocol, which is, of course, hugely popular for textual languages, but apply this architectural pattern to diagram languages or graphical languages in a way that you still get the same benefits in terms of that you can do the front-end development entirely browser-based, whereas the front end really stays only focused on rendering of the diagrams and user interactions, and the back end is really doing the heavy lifting in terms of model management, manipulating the model, implementing the language editing rules, and all these things. So Eclipse GLSP obviously is open source. You can find it on GitHub on this URL, which is pretty small, but I'm sure if you Google it, we will find it as well. And essentially, it provides four types of frameworks. It provides, first of all, a set of server frameworks in Java and in TypeScript that you can use to build your specific diagram servers for instance, UML, BPMN, or whatever language you like to build, and build that on top of these frameworks, either in TypeScript or in Java. Then it provides and defines a protocol that is being used to communicate between the server and the client, whereas these protocols already define quite a lot of messages that are typically useful and needed for the standard diagram editor. It's still also extensible to add your additional domain-specific communication means on top. Then there is a client framework that's written in TypeScript, that you can then use to implement the rendering, how your diagram actually runs in the browser and renders in the browser, and implement your user interactions and editing tools on top of that. And last but not least, there is a set of platform integrations that you can then use to integrate the diagram editors that you've been building with GLSP seamlessly into web applications, VS Code, or Eclipse Thea, or Eclipse RCP. So how the communication between the client and the server works is essentially as follows. When the user opens a diagram, basically the client is opened and sends an initialization request to the server with some init parameters, for instance, a file URI or a diagram type or whatever you need on the server to be able to identify the correct data source that you should be loading and the correct diagram. So that's then sent to the server, and based on that information, in the next step, the server is responsible for loading the source model, which is really the data source that you need, that contains the information that you need for building the diagram. This source model can be a file, it can be an EMF model, it can be a JSON file, it can be XText-based, or even a model server like EMF Cloud or a database or a REST API. It doesn't really matter, because that's the code that you need to provide anyway in order to specify how to load a code. That being said, of course, for the very popular choices like JSON and EMF, there is even better framework support out of the box so that you don't have to code so much yourself, but essentially you can choose here whatever you like. Then, in the next step, your server will transform this source model into a so-called graph model that then specifies how this data from the source model is to be rendered on the client. And the graph model is essentially a structural description of your diagram consisting of typed nodes and edges that is then sent as a JSON essentially to the client. And the client then uses this graph model to render it directly in the browser as SVG. And for that purpose, we use an excellent open source framework also of the Eclipse ecosystem, EclipseSource, which is really focused on that task of basically taking an abstract diagram representation and rendering it into SVG based on Vue implementations, and then show a beautiful diagram in your browser. Of course, then you want to interact with this diagram, and therefore there is then in the client framework a set of editing tools. You can think of it as keyboard and mouse listeners essentially, that then transform these UI events into actions that can then be sent back to the client, back to the server in order to, for instance, change the model and so on. So the flow would be if you create an element here in the client, this editing tool will send an action, a request for change to the server. The server would manipulate the source model directly, your format, and would then regenerate the graph model and send a graph update to the client so that your change is essentially also visible in your client. Besides that, there is a couple of other actions, like for instance, what tools are available in the tool palette, or resolving navigation targets and so on. So there's different messages, and you can then even add your own custom messages on top, as I mentioned before. So with that, just a short overview of how things work. Let's have a look at a demo. What you see here, hopefully you see it well enough. I can maybe even change it to light. 1 second. Like here. You have here an Eclipse Thea application running in my browser, and for the WF file extension, there is a GLSP editor registered. So when I click that, essentially a nice diagram should be loaded. Now it loads, sorry. And essentially this WF file is a JSON file, and we just saw happening what I explained before. The JSON file is read on the server, translated into a graph model, and sent back to the client, alongside with several other things like the palette items and the configuration of each element type and so on. So now the user can then, of course, besides everything else what you would expect in a diagram editor, panning, zooming, and all these things, can start to modify. So for instance, here change the label, add new tasks, create new edges, and so on. And of course, there is many other features that GLSP more or less supports from the framework out of the box. That's, for instance, validation. So if you add an element where a validation rule says that it is not allowed to have just a decision node, as here in this case, you will get an error marker and also, of course, an error message when you hover over it, which would then just go away as soon as you actually do something to solve this error. There's also then other functionalities that are integrated by default, like auto layouting and things like that based on the Eclipse layout kernel, and many other more features which you can then adopt to your specific use case. Right. With that, just let's move on to what is new with the Eclipse GLSP 2.0 release. So as you can see on this slide, there is a lot of dots because it didn't fit on one slide, so I only choose a few things that I wanted to highlight. So for instance, in the framework functionality, there is now much better support for JSON source models because that became more and more popular in the last years. So you get undo, redo support, for instance, out of the box there. There is now dynamic edge hints so that the server can actually decide whether you are allowed to connect to elements or not. There is reconnectable server connections, which is super important for cloud deployments where the client and the server is actually remote and not running on the same machine like in Electron or VS Code. In the Eclipse integration, Eclipse RCP integration, there is even now a native E4 support, so you can use that in E4 applications quite easily. There is now front-end only support that the server, when it's written in TypeScript, can actually also run in the browser, which is again really convenient for cloud deployments because then you don't need to have a back-end running just for one user. You can just run that in the browser directly. There is live validation, batch validation, server progress reporting, and many, many refactorings that improve the API and make your code much cleaner. However, I promised the 3 most innovative features, and that's basically these 3 features that I want to really highlight and go into more detail. And that's first of all end-to-end testing support, then improved accessibility of the diagram editors, and synchronous diagram editing. But because it's not enough to just demo 3 experimental features, for some reason I thought I should make this even more a challenge. So I will try to demonstrate these 3 new features by applying the same 3 changes in 3 different ways in 3 different platforms in the next couple of minutes. So the first one is automated testing. I will write the test where you basically do these 3 changes in an Eclipse CA application automatically. Then I will try to apply the same 3 changes in a standalone application by only using the new accessibility features. And last but not least, I will do the same changes again in VS Code in a collaborative modeling session. So let's start with the first one, testability of diagram editors. So we all know, of course, complex diagram editors are contain a lot of logic and functionality, so I don't need to convince you that it's extremely important to have great testing support, and that means that your diagram editor needs to be testable. Looking at this typical pyramid of testing or test coverage, the first 2 layers, unit testing and integration testing, always has been pretty nicely supported because on the client and the server we build on dependency injection. So that means your code that you develop for your particular server or your particular client is essentially just a plain class that gets all the dependencies and data injected. So that's then easy to isolate and write unit tests for, right? However, end-to-end testing, the upper area of this testing pyramid, is supposed to directly interact with the diagram UI, and that means it has to interact with the SVG, and that's really challenging, right? Interacting with SVG in the browser with a browser automation framework is very, very challenging. So what we did, and with we I mean mainly Haider, the excellent student that I mentioned before, together with Dominik and from our side Martin Fleck, was to develop a GLSP object library, which essentially is here, that contains a set of reusable functionalities that you can then use in order to build your page object model for your particular diagram editor. And with page object model, this pattern, the idea is that you then write your tests not against the SVG directly, but against this page object model, which are then on a much higher level of abstraction, so that you can say, okay, move this node now 50 pixels to the right, and now then rename this node from A to B, and so on. But you don't have to find the respective elements and trigger UI interactions there directly. And this page object library is, of course, generic and extensible, and then can be combined to your specific page object model. And all the implementation in terms of directly interacting with the UI is then implemented based on Playwright. One really nice aspect, in my opinion, is also that you can actually, that the framework is built in a way that you can actually write your tests in a way that then not only test the diagram editor in one integration, but you can run the same test against multiple integrations. Since GLSP supports VS Code, Thea, Eclipse, and so on, you can basically run the same test and make sure everything works as expected in all the different implementations without even changing your actual tests. So that's really nice. So how does that look like in code? You have here on this basically the GLSP page object library, and essentially what that contains is 3 types of things. It contains capabilities, basically that defines what an element has. Then you can define flows. That's essentially what you can do with elements. And then it contains models, and that's basically the idea that you would then define your model for your particular diagram by combining for each type that you have in your diagram these capabilities and flows together to reuse those predefined functionalities in the object library. So for instance, for this manual task, that's just if you remember, that's this guy here, you would basically, for instance, define, okay, it's a node, it has the capability of resize handle, so that means you can actually resize it, and you want to add the flow that it's draggable and that it's deletable, and with that you get a lot of functionality already out of the box. Then you get here this class here that you can then use in your model as a superclass, and maybe also add even custom methods to it, convenience methods and so on. And with that, then your test is written against these model classes. For instance, then you say, get node by ID. Since it's a labeled element, we know how to find it. Then you get a node, and then you can drag to relative position because that's implemented in the draggable flow. And with that, you can then define your tests on a rather high level. So let's have a look. Let's just close that here. Let me just make sure that the server still is running. Yeah. So here, let's have a look at an example test. Just making sure that's somehow readable. Should have switched to light mode before, but I guess it's theme here. It's fine here. Right, so basically what we have here is a normal test. So you describe a test where you specify that before each test you want to load a GLSP application. And this abstraction here is there in order to make possible to run the tests that you define below for arbitrary integrations, because it gets as an input the respective integration and what's specific for this particular integration. And then you can use basically the API from this app to access the graph and, for instance, get a node by label and say which type you expect. And this is exactly the type that you've specified before with the API, as mentioned before. So let's have a look at the task manual here. So we see here, we have here these definitions, what flows and capabilities this guy has. We can then, in addition, add certain custom methods to it. And then we get here a task node. We can drag it, we can rename it, and we can then here move it to a certain position, and we can then even create an edge of a certain type. For instance, this create manual task and create edge. These are then additional methods that you can write in your GLSP application code just to collect convenient methods to make your your test code even cleaner. And with that, let me just really make sure, because before I've seen, yeah. With that, you can then just execute this test. Here, the configuration, we have a configuration for standalone Thea and for VS Code, run and debug. And you can then even nicely debug this test. Let's see if that works. So now a window is opening that already did something. We didn't see really what. It took this guy and moved it down. Yes, that makes sense. And it renamed that to hello. Yeah, makes sense as well. And now we hit the breakpoint here. And the next step is that we move this. Oh, we already did that. The next step is then creating a new manual task with the name EclipseCon, and then create a new edge. So let's see if I can put that side to side here, that we see a little bit more like that. So we can then now jump to the next step. Now the node is created, renamed, and the edge is created. So that's the first way of doing changes. You can from now on not edit your diagrams, but really write everything in test code and do it like that. Of course, the same thing, just to demonstrate that, I can also now to run the same test in the standalone integration. So execute profile and do it now in the standalone way. So basically, it's exactly the same thing. But of course, the way how the diagram is opened is different because we are now running in a standalone application. So as you can see here, there is no file explorer and so on. But of course, I can still run the test, the same test with the same behavior. Right. So let's continue with the next demo. Yeah, that's accessibility of diagram editors. So obviously, accessibility is a huge topic and very, very important to consider in your applications, and that's also true for diagram editors. Diagram editors in GLSP always had a few accessibility features already, and that's, for instance, adjustable zoom levels, then theming support, including high contrast themes and so on. But of course, there is many, many more challenges that is especially very difficult to handle in diagrams because you're dealing with graphical positions and so on, and making them usable without, for instance, having to use a mouse and so on is particularly challenging. So what Eileen, Dominik, and from our side Nina worked on is to add new capabilities so that you can use the diagram editors in a very keyboard-friendly way, have assisting indicators and metadata on the SVG so that you can even build assisting technologies based on those. Of course, challenges like dealing with graphical locations, text-based navigations, and semantic and graphical navigation is something that we had to face. But I really don't want to go more into theoretical detail, but show it live. So just I have to switch the demo, because now we not want to show that in Thea, but we really want to show that in the standalone integration. So as you can see here, I have just a normal diagram editor, and I will try now not to use the mouse at all. And to prove that, I will use a tool called Screen Key, which should, I think, show on the screen the keys I'm typing. Yeah, so now space. Yeah, I should actually use a key that changes something. And now I want to do the same changes. So first of all, of course, you can zoom by just hitting plus and minus. You can use the arrows to pan, so that's already fine, good. But now I want to select a node, right? What you can do is basically you can use a search functionality. And with the search functionality, you get a list of all elements, and then you can step through them and get a highlight of something. That's one way. Or you start typing, which is then really nice because it highlights the elements and grays out all the elements that don't match the filter. And then I select push. So now I'm centered on that. And I can then, since I have one element centered, I can now start to move this down, hit F2, and write welcome to enter. Okay, so far so good. We did the first two changes. Now to the more challenging ones, I want to create a new node. When I want to create a new node, I have to use the palette. So I use LP, and with that I switch into the palette focus. And in addition, you have these indicators which show you which key you press in order to activate a specific tool. So for instance, I want to create an automated task, so I hit A. And now the challenge is, where do you want to put it? What this tool now does is it puts your canvas into pieces, and then you can already select the area where you want to create it. Here, for instance, this is the area where I want to create something, so I select 9. And now, unfortunately, you can see it because there is no hidden. Now you get this green indicator, which gives you more fine-grained control, and I can again use the arrows. I move it up a little bit so that you can see the green thing again. You can use the arrows to select the position, hit enter, and then the thing is created. Nice, right? Then, of course, what we want to do next is we want to create an edge. So again, what I can do is I can not use this one, select the welcome to, and use the command palette that we've already been providing all the time, and start typing edge, and then you can select where to create an edge to. So that's one way of doing it. Another way is again to use the palette. So I'm using again Alt-P for the palette, and then I select edge. Sorry, I select edge, not P. I select edge, which is H. And now I select first the target, which is welcome to, and then I select the automated task, which I forgot to rename yet, and then I create a new thing here. Of course, now the last step, just to complete that, is to select this one and rename it to EclipseCon. Done, ready. And another cool thing is now, of course, you very often want to navigate through your diagram, right? What you can do now is essentially here, when I use the arrows, you move it, right? But you can switch into the navigation mode by just hitting N, and then you actually walk through the diagram in a logical way. So when I'm now on welcome to and I hit right, then it selects the two edges, and I can decide now whether I want to follow the upper edge or the lower edge. If I select the upper edge, then I can continue with that, go here, and really walk through the diagram. The second way of navigating is, you see that here, really small. is to use a geographical or spatial way of iterating through elements with your arrows, which then uses the positions. So that's really cool as well, I believe. Yeah, I think that's essentially what I wanted to show in this area. So I will just also close now this, and I guess we don't need the screen key anymore. Right. So that brings me to the last feature. So the previous two features are already available in the 2.0 release as experimental features. So they are optional, so you have to activate them. But they are available. This particular feature is in a separate repository right now and not part of the release yet, but we plan to make it part of the release very, very soon. So what is this feature about? It's really a cool feature that we've been requested quite a lot, and that's enabling real-time collaboration similar to Google Doc, but on diagrams. And that's something that Markus, Dominik, and on our side Tobias worked on. And we had pretty strict requirements here. We wanted to avoid having or enforce a central proprietary model server that we put somewhere in place. But what we rather wanted to have is that you as a user of this diagram can decide, now I want to share my workspace and invite other guests to join, because we don't want to break any of the existing diagram implementations, which are very often file and workspace based and not model based. Also, we wanted to ensure that this collaboration feature is compatible with arbitrary customizations on the client and the server, so it should work for all GLSP diagram editors out of the box. And what's very, very important to our adopters is that the collaboration not just works for the diagram, but really for the entire tool. So it doesn't really make sense if you have a tool that has form-based editors, diagram editors, and textual editors, that the collaboration only takes place in the diagram editor, right? So we wanted to enable that. So what we did is we implemented a generic solution for this diagram collaboration for GLSP and have a concrete implementation for that particular solution based on VS Code LiveShare. So it already works now in VS Code LiveShare, but it will soon to be integrated as well with the upcoming Thea support for the collaboration mode that is coming up in the next couple of months in Thea, so that you can do whatever you see here also in Eclipse Thea. And of course, this integration is built in a way that it can be implemented in arbitrarily other collaboration systems, because it's really, I will go more into detail, it's really generic in that sense. So let's have a look at how that looks like. Here I have already a Visual Studio Code open, so I'm the host now. What I do now is I start a new collaboration session. So what this will do, it will just on a registry say there is a new collaboration session, and it copies the ID to connect to that session into my clipboard already. So what I can do is now it gets complicated, so bear with me. I will open a second Visual Studio Code where on this side I'm now the guest. So I want to join a collaborative session and just, it already pasted from the clipboard the ID, and I will join that now. So now, by default, this will open in this restricted mode, but I want to trust my guests, my host, since it's myself, it should be fine. And now I'm connected. So you see, I'm getting exactly the same workspace as the host, and I see that there is now already one participant, which is, again, surprisingly, Philipp Langer. What I can do now is I open the diagram, and it gets now really small here, and use this diagram, right? And the other person, again, can open the same diagram and use the same diagram as well. But what is really hard to see, and maybe making this a little bit smaller, is, and zoom out, that you also get an indicator of where the other person currently is and what's the range that this person looks like. When this person selects an element, you see here on the right-hand side that there is a marker of where this other person is currently with their selection. And of course, it's working the same way in the other direction as well. So let's just do our changes. I go now here, and on the left-hand side, I move this element down, and on the right-hand side, it directly updated. That's pretty cool. So on the right-hand side now, I create a new element here, which automatically appears on the left-hand side, and I can create an edge in a similar way. and it's appearing on the left-hand side as well. So they are really sharing the state. And what's really cool now is that they are sharing the state, that's fine, but still both should have their own command stacks, right? So when I, for instance, move something here, and then I move something here, and on the left-hand side now, I undo the change, I undo this change, I redo it again, and if I go here and undo this change, it only undoes the change that this user actually did, right? And that's really nice. Of course, this collaboration, as I mentioned before, doesn't end with diagram editors, so you can also directly now go into text editors as well and have the nice experience that you all know from Google Docs. And this is then also possible for form-based editors to be implemented and so on. So that's really collaboration independent of a central model server across the whole tool, and that's what we were targeting at. So really just very short how this works is essentially the host tool publishes initially a session, so there is a registry, in this case it's LiveShare, which holds the currently active sessions, and the second user can then join a session by ID. And as soon as the session is joined, there is actually a direct peer-to-peer, end-to-end encrypted connection between the two collaborators. And once this happens, there is a GLSP coordinator component started up, which sends an initialization request to the server so that it establishes a second command stack for this additional guest, but only one model state, because that's what we still want to share, right? And the nice thing is that this extension of the server is really generic, so it can be added to any existing server. And this coordinator then would trigger also this initialization, which triggers an update. And this coordinator knows which actions to broadcast and which actions to really only provide to one single of the guests in the session. Basically, it marks the actions from which they were occurring, and then knows where to distribute them. Of course, if there is then some change, so for instance, the guest applies a change, this is then sent to the coordinator. The coordinator sends this operation to the command stack, to the right command stack, applies the change to the model state. Then there is an update model, which is then updating the host. But the coordinator knows, update model, I have to broadcast to all guests, so this will then also be updated to the guest again. And this is how this is essentially implemented. Right. That's basically it. I'm happy that all the demos worked. So just a few words, and so that we have a few more minutes for the questions. So GLSP version 2 is available. There are several major improvements. I just brushed over them really quickly, but shown new experimental features that we have. And all of these features really are built in a way that the core values of GLSP, the flexibilities with respect to model management and format, server language, or tool platform and deployment is really kept in place. So I really invite everyone to check out the new release and talk to us about potential adoption for this technology. And also I want to invite you to a couple of other talks that are related. So there was already today, just an hour ago, a very nice talk about Sprotty. So make sure to catch that later on YouTube once it's online. Tonight there will be a Birds of a Feather session on building web-based tools, where GLSP is also a topic. And tomorrow there will be a talk by Maximilian at 11:30 about building modeling tools with a full TypeScript-based stack, so no Java on the back end, for a homogeneous developer experience. And with that, thank you very much. Don't forget to rate this talk if you liked it, and I'm happy to answer all questions. Thank you.
Test.
Yeah, this works.
Yes, I would like to know, how do you handle the user command stack when there are conflicting commands which make a command invalid? For example, I create user A creates an element, a node, user B renames it, user A undo, so the element is deleted, and the renaming command is not an executable. Do you switch to the previous command? Do you raise an error?
Very good question. So we apply the same strategy that is also known from Google Docs. So we have no particular conflict detection in place, because as the changes are applied synchronously, there is using, at least theoretically, using the chronological ordering, it's always made sure that the change can be undone. And if it by that overrides a change that the other person has done, then so be it. That's not handled like in a Git merge or so, where you really want to make sure that all changes are merged in the end and really every conflict is detected. Because when you are starting to collaboratively edit, you don't want to stop users from doing that just by saying, you now did something that conflicts with someone, because the user sees the change directly anyway. So it's expected that the user will be aware of the change and can deal with it. But very good question. I don't know.
Sorry. Are there any breaking changes to the new release? So if you use an older version, and is there some how-to for that?
Yeah, very good question as well. So yes, there are unfortunately a few API breaks or improvements. Also based on the base technologies that we use. So for instance, GLSP 2.0 is now based on Sprotty 1.0, which is of course also has API impact on GLSP. And there is also a few other improvements. However, we have upgraded all the examples in the example repository. So that's one clue of how to upgrade your tool. And we will also improve or enhance the documentation to give more concrete steps. And of course, there is a change log which links to all the pull requests. And if you get stuck anywhere, feel free to use the GLSP discussions or contact me directly to help you. Thank you.
Very impressive. 2 questions. First of all, synchronous editing support. I don't see anything stopping us from having more than 2 players in it. Can you support more than 2 players, except for not on one screen during a demo?
Yeah, great question. So I think there is 2 sides to this. So first of all, the collaboration support in VS Code Live Share, I think, supports up to 60 people, 60. So that would... in theory, it would work. However, of course, you have a certain performance overhead because you're getting the updates of 60 persons all the time into your diagram, theoretically. So that's why in this implementation, currently you saw every person's viewport and selection and mouse position and so on. So you should then turn these off, because otherwise you would get flooded with a lot of updates, and that would cause a lot of re-renderings. Yeah.
EclipseCon regarding, I believe it was GLSP with Langium integration, and would they be able to? Do you know if they're going to be demoing more of these new cool features from 2.0?
I don't know, but I will talk to them. I actually don't know if there's any demo planned, but it would be great, of course. But what is really nice is if you have a cool modeling tool that has textual and graphical languages, you can use the collaboration feature for both of them really nicely without having any glitches in between. So that's pretty cool. There was one last question, maybe?
I can ask that.
Okay.
Is it possible to use some other figures or decorators in the graph? Like, I don't know, different class diagrams where we have 2 input boxes?
Yeah, sure. So definitely.
But is it a predefined set, or can you expand it and put stuff?
Yeah, so just because it was not in the mic, the question was how flexible is the rendering, what types of shapes you have. So essentially, there is no limit. The only limit is SVG. Whatever you can draw with SVG, that you can put into your diagram. So the idea is, and that's basically the support of Sprotty, is that you have the graph model, which is basically the structural description, has typed nodes and typed edges. And for each of these types, there is a view implementation being registered. And in this view implementation, you transform that node into an SVG shape. And it depends on how good you are with SVG. I'm medium good, but I'm still was able to draw whatever. So here is a class diagram, here is a function block diagram, and there is even nice, if you go to Eclipse Dev GLSP, there is a gallery of hearts, 3D figures, and so on. So there is no limitation. The only limitation, of course, that there is the more complex your SVG gets and the larger your diagram gets, you need to also start thinking about performance, because typically the more elements you have in your diagram, the slower the rendering is. If you have then thousands of elements there, then you need to, for instance, apply strategies like if you zoom out and really 1,000 elements get visible, that you reduce the detail and stuff like that. And there is, I think, a great talk that has been just before this talk on YouTube that really focuses on that. So I think technology-wise, there is no limits. Great. Thank you very much. I think time is over. Thanks.